My name is John Elfie. I'm an applications engineer here at Heat Pipe Technology. I handle the northern states, Northern Territory, basically from Arkansas up north through Canada. So I handle, for the most part, energy recovery systems. So today's webinar is going to be focused on SelectPlus and actually selecting the right side-by-side energy recovery heat pipe. Before I start, if you haven't already done so, I would definitely recommend signing on or registering for our online software. It won't be, if you don't have SelectPlus, it won't be that critical. The examples that I'm going to be going through, they're going to be fairly basic. It's really to give you guys a general layout of SelectPlus, things to look out for. Before we begin, here's a quick little outline of what we're going to be covering. First off, what are heat pipes? For those of you who aren't familiar with what a heat pipe is, I'll briefly get into that. Then also I'll talk about the right heat pipe based on location. And then I'll follow that with some selection examples. And then I'll do bin analysis, which is a very powerful tool that we have in SelectPlus that can help you select the right side-by-side model. And then last but not least, I'll wrap it up with some helpful tips and shortcuts. All right, so moving along. So what is the heat pipe? Again, for those of you who aren't familiar, it's fairly straightforward technology. It's been around since the 60s. NASA actually developed heat pipe for the space industry. Basically, heat pipe is a closed vessel. In our case, we use half-inch copper tubes. And inside, you would have a working fluid. Either what we use here is 134A or 410A. And if you guys take a look at this graphic here, as you apply heat to one side, what happens is the refrigerant inside is actually in a liquid state. So as you apply heat, that refrigerant absorbs that heat, it boils or vaporizes, it travels over to the cold side where it rejects the heat or gives off the heat to the surroundings. After that, it condenses, comes back around, and the cycle continues over and over again. So as long as you apply heat to one side and you inject heat to the other side, that heat pipe is going to keep moving energy from one side to the other. So what I have here is, if you guys can see, I have a little line down the center. In a simple form, if you guys think about dividing this in half with a partition or a gap, this is really our side-by-side energy recovery models. What we've seen is with a tilt, and actually as you start tilting this heat pipe to 90 degrees where you have a vertical tube, gravity greatly improves performance. And you can see that if you do some comparisons in SelectPlus, how that performance changes with our tilted models and our over-under models, which I'll get into a little bit later. But gravity definitely helps improve performance, so that's something to think about. So that's a heat pipe in a nutshell. We have tons of literature on our website, so feel free to go online and check that stuff out. A basic description of what a heat pipe is. All right, so before I get into what or where to use the models, I wanted to give you guys a quick little preview of what models we actually offer. And these are just specific to SelectPlus. So this is what you can go online and run selections for. We do have other models which are split passive in our new glycol loop system. But for this presentation, I'm just focusing on what's available in SelectPlus. So first off, we have what we call an Atrium Z. That's optimized for heating. Z standing for optimized. And what we've done here, if you guys see, there's a little angle indicated by theta. What we've done is we've actually implemented a fixed slope, not to be confused with the dynamic slope. We actually tilt depending on the season. This is a static tilt. And the tilt actually happens from the exhaust side, which is your warm side. That's where you want to apply heat. It's always at your lower airstream. So the slope goes from the exhaust side up to the outside air side. So that's optimized for heating. On the flip side, we have optimized for cooling. And if you guys see here, the slope occurs from the outdoor air up to the exhaust, because during summer, that's going to be your warm airstream. And followed by HRMO, and O actually stands for over-under. This is where you have applications with stacked airstreams. This is single season recovery. It is going to give you the best recovery out of all the models that we have. But one thing that you have to consider is you want to make sure you have the correct airstream on the bottom. So say if you want to get heating recovery, what you need to do is you need to make sure that that exhaust airstream is on the bottom. For summer recovery, vice versa, you want the supply to be at the bottom because that's going to be your outside air or your warm airstream during summer. And last but not least, we have our HRMH. That's our standard model. H denotes horizontal tubes. This is what we call balanced recovery. And by that, what I mean is if you, whatever effectiveness you would see in summer, you're likely going to get the same effectiveness during winter. But generally, compared to the other models that we have, this is going to be the lower performing model. The HRMO, again, is going to be the best performing. So the HRMH is sort of what we started off with as far as energy recovery is concerned. And then from there, we started developing the HRMO, and then the most recent was the HRMZ, optimized for cooling and optimized for heating. So that's our basic side-by-side products in a nutshell. Let's keep going on here. So when and where to use? From what we've seen and some of the analysis that we've done, really when you're determining what model to use, location is an important factor. So what we've seen is for northern states, really those states you're going to be primarily in heating mode. You're definitely going to have some cooling hours. So from the analysis that we've done is the fact that you're in heating mode for the most part, it would make sense to optimize for heating, and that would be HRMZ model that we offer. Now, on the flip side, the HRMZ optimized for cooling, well, you would really want to think about using that in the southern states. Now, I know energy recovery isn't something that's really thought of in the southern states. You're probably more worried about dehumidification. However, there are applications where energy recovery is needed in the southern states, and we've seen that here at HPT. And in these middle states, if you will, where you have more of a mild climate, you might have more balanced cooling and heating hours. Well, there, what we've seen, it would make sense to use an HRMH because you have that balanced recovery for winter and summer. So this is obviously just a general guideline. Things can change depending on an application. I mean, if you have a process application, you know, this, what I have here, it might not follow, might not be the best practice. But as a general guideline, this is what we've seen throughout the years and what we sort of push people towards when they're trying to decide what model to use. Now, when it comes to HRMO, because we're only dealing with single season recovery, we tend to see that line, when you're worried about heating only, sort of gets shifted a little farther north to where your cooling hours are even less. So you're really just, again, worried about heating. That's where most of your load is during the year. And again, on the flip side, HRMO, cooling only, you're going to see that extreme southern states. And one thing HRMO is actually very good for our process applications. We've actually done quite a bit of data center jobs where HRMOs are used. A data center, you have basically constant temperature coming out of that space, and all you're looking for is just cooling. So an HRMO is a perfect example of an application to use for a data center. It might not follow this map that we have here, but it's a perfect application for that type of model. So hopefully that makes sense, pretty straightforward. I think one thing that will help kind of explain what I just talked about as far as region is when we're looking at energy recovery, not only are we worried about design conditions, but another thing that you want to think about is annual energy recovery, or BTUs. So BTUs, that's where the savings comes into play, the dollar savings that you have in a year. So if we take a look at an example where we have a 10,000 CFM system and its size is 500 feet per minute, and you can see there the exhaust air conditions, 72 summer, 70 winter. Well, what I've done here and what I'm going to show you is energy recovered in a specific location. And in this case, what I have is Boston, Massachusetts. So all of this information is coming from SelectPlus. I was able to convert it into a chart to show you guys graphically what's going on. And in Boston, Massachusetts, what's happening here is on the left-hand side, we have bin temperatures, or bin temperature ranges. And up top here, we have hours. So the blue indicates cooling hours, followed by the white where it's indicating Economizer Mode. And below the orange, we're looking at heating hours. So it's pretty evident that a location like Boston, your majority of the year is going to be during a heating mode. So what does that mean as far as energy recovered? Well, if you compare the three products that we offer, which I just talked about, over here on the left-hand side, we've got our HRMH, remember that's balanced recovery. Then in the middle, we have our HRMZ optimized for heating. And then to show you guys sort of a difference or dramatic difference is our HRMZ optimized for cooling. So here you can see that our HRMH, if it's not clear, sorry guys, there you go. You can see here our HRMH, we're recovering about 760 million BTUs per year. Now, followed by our HRMZ, that actually jumps up to 810 million BTUs. So that's roughly a 7% increase in recovery. Now, even though, actually, if I take a step back, what I didn't mention before is, even though we're optimizing for one season, we can still do some recovery in the off season. So it might be a little difficult to see, but our HRMH in cooling mode is recovering a little more than our HRMZ, but what we're gaining in the heating season actually is greater than what we're losing in the cooling season. And overall, we're recovering about 7% more BTUs in a year, and that's going to be attributed towards savings for your client or for your customer. So again, this is just to show you that it's not only about design conditions, maybe downsizing equipment. I know there's applications where that's very important, but another way to look at it is also the BTUs that you're recovering in a year. So I hope that makes sense. I know that's, I might have gone through this kind of quick, but again, if you want to ever go back to anything, this is going to be available online. There's the recovery that we're looking at for optimized for cooling. We're looking at about 520 million BTUs. All right, so our examples that we're going to look into, getting into SelectPlus, we're going to do one example HRMH, and we're going to do Salt Lake City, summer and winter design conditions. We're going to size that system at 12,000 CFMs, 12,500 CFMs, and 500 feet per minute. And then we'll also do one example with HRMO. It's going to be winter design conditions in Toronto, a slightly bigger system, 20,000 CFMs, and again, sized at 500 feet per minute. So what I'm going to do now is I'm going to open up SelectPlus, get out of this presentation here. Hopefully you guys are still following along with me here. So let me go ahead and sign in. There we go. I'm kind of assuming that you guys are somewhat familiar with the layout of SelectPlus initially, but real quick, this is when you first sign on, this is your main dashboard. To get into all your projects, you would click up here in the top. And I only have a few projects here. This is a fairly new account that I created, but obviously you can have as many projects as you want, and you can have as many pages as well, which are indicated here on the right-hand side. So what I'm going to do is I'm going to add a new project. So I'm going to create, let's call this HRM webinar. And then I'm going to add a new project. And this page can be useful. You can put information, specific project information that if you ever need to go back and kind of remind yourself, it's there for you. Let's do project type other. So that's fine. And there we go. I just created the HRM webinar project. So to get into this, I'm going to click the schedule icon. And this takes me into my first project schedule screen. Before I keep going, one thing I want to mention is we do have a YouTube channel. And within that channel, we have several 2 to 3 minute long videos where we cover different topics in SelectPlus. So if you ever want to know how to create a project or how to go through a bin analysis more in depth, then we do get into that. And they're very short videos, definitely manageable, about 3 minutes, 4 minutes, maybe is the longest video. So you can just search for us on YouTube, Heap Up Technology, and we've got a channel there. All right, so I'm going to create a new line item. I'm going to change product type to energy recovery. And I'm going to click the add new line item. And then what I'm going to do is get into the main selection. All right, so this is the main input screen. Just kind of going quickly through this. Looking at the top left box here, we've got some inputs. You can change your quantity. If you've got identical systems, you can update that to whatever, 2, 3 systems that you have. Tag, input whatever you want. Since we're doing Salt Lake City, let me do Salt Lake City winter. I'm gonna tag it as that. Remember, this is gonna be an HRMH. If you guys recall that map that I showed you, the HRMH would likely be the best model to use in this area. So we're gonna do horizontal. And you can choose the air type, standard, or actual elevation. I'm just gonna keep it at standard, just to simplify things right now. In the center, we've got some options. We've got construction options, copper, aluminum fins. We do our fins per inch, refrigerant, 134, 410A, and also our coating. Got electrofin or hair site. Moving along, our other options or selection options. We have a capability of adding evap cooling on the exhaust side. It's going to enhance performance. We can do Economizer Mode on the supply side. We can do frost control, and what's going to happen is SelectPlus, if you have frost control checked, it's going to run calculations where it actually bypasses around the supply side so that your leaving exhaust temperature doesn't fall below 36 degrees. So that's sort of the sweet spot as far as the temperature goes, that you don't want to be below on your leaving exhaust side. And this below here is the supply and exhaust separation. I'm going to do 2 inches. And if you need to foam fill that, you can. You can just check that box. It's an option that's kind of overlooked. I know it's a little hard to find, but that is the area where you want to select your gap. And then we get into the main input conditions. So as you recall, I mentioned 12,500 CFMs. And we're going to do winter design conditions, Salt Lake City. And that's roughly 11 degrees dry bulb, 10.4 wet bulb. I'm going to size at 500 feet per minute. And the dimensions that I've already chosen are pretty arbitrary. 60-inch fin height by 60-inch fin length. Start with 6 rows. And then if we move over here to the exhaust side, again, 12,500. And let's do 70 degrees dry bulb. And our RH is going to be 40% RH. So that's a good starting point. Let's see. I'm going to unselect frost, see what happens, so you guys get an idea of full performance without having to bypass anything. So if we click calculate, these are the results that we're looking at. So if you can see here that we're doing around 54% effectiveness, a little more actually. We're going to show the pressure drop on each side. This is the pressure drop on the supply side. If we move over to the exhaust side, we actually show the pressure drop. And if you take a look, that pressure drop is actually different. It's higher. So we're looking at 0.71 inches H2O compared to 0.57. And if you're not sure why, and I get this question sometimes, the reason why is because the exhaust side is actually condensing. If you take a look, there's two things that are going to stand out. One is we have condensation here, a little over 41 pounds per hour of condensation. And another indicator is that our temperatures here are saturated or leaving exhaust. So we're looking at about 100% RH. So when it comes to condensation on heat pipes, condensation actually definitely drives up performance. I'll show you here in a little bit what happens when you don't have condensation, how that performance changes. So if you see that discrepancy with static pressure between supply and exhaust, and if you see that bump in effectiveness, it's likely because the heat pipe is condensing, which is going to drive up the pressure, and it's also going to drive up performance. All right, so that's the results there. I'm going to go forward here, continue. This is the drawing screen that we have. A couple of things to point out. We do offer the option to provide bypass if you choose to do so. There's a little option here to select it. If you select it, the drawing gets updated with the bypass. So we don't really offer this too much. Typically manufacturers have their own bypass that they want to use. So it's an option that's there, but we just don't get a lot of requests for it. So if I uncheck that, the drawing again gets updated. And we can choose what kind of frame that we want, either galvanized or stainless steel. I'm going to keep it, let's do stainless steel. Just get an idea. You can see all the description gets updated within the drawing. So we've got our copper, our fin material, number of rows, FPI, all that good stuff. All right, so that's the winner selection for Salt Lake City, Utah. I'm going to keep going, so I'm going to do save and close. And one tip that I want to sort of show you is we're going to go through and do a summer selection for Salt Lake City. In order to not have to create a new line item and input dimensions again, rows, all those parameters or inputs, one thing that we can do is if we select that line item here on the left-hand side, we can actually copy to this same project just by clicking to that little copy to icon. And you can see that that line item is duplicated. So then what you can do is go back into that selection, and instead of having to input your dimensions, all you have to do is just input your temperatures. So summer design temperatures for Salt Lake City, Utah, we're looking at 96 degrees dry bulb, 62 dry bulb, and moving to the exhaust side, we have 75 and 35% RH. All right, so if we click calculate, this is where you're going to see that difference in performance. So before we're looking at around 54%, but now we're looking at around 45%. And again, the reason why is because we're not condensing. The heat pipe is not condensing, so there's no latent recovery, which enhances performance. And if you take a look at the pressure drop, it's about balanced between the supply side at 0.65 and the exhaust around 0.64. And again, because we're not seeing any condensation. So that is the summer conditions. What I'm going to do right now is show you guys an example for an HRMO. Again, if you guys have any questions, you can definitely type them down in the chat screen that we have there, and towards the end, I'll answer everything. All right, so moving along. All right, so what I'm going to do now is actually create a new line item since we're doing a completely different model. So again, add new line item and go into the selection. If you want, you can change the model here. I just prefer, to me it's easier just to go in there and change it within the selection just to be consistent. So we're going to do Toronto winter, and we're going to change the model type to over under. And let's keep all these the same, 12 FPI. Let's do frost control. So we didn't reach frost control at Salt Lake City. Let's see if the HRMO actually gets to that frost threshold. All right, so we said we're going to do 20,000 CFMs. And winter design for Toronto, 3.4 dry bulb, 2.7 wet bulb. One thing to note is when you have an HRMO, what's happening is we're really taking an HRMH and rotating it 90 degrees. So you're going to have vertical tubes and horizontal fins. So your fin height for an HRMH really becomes your face height. So that's going to be your height of each tunnel, the height of your supply and the height of your exhaust. And the fin length, in our terminology here at HPT, we classify it as face length. So face height and face length. So the face height that I'm going to use, 60.5. Face length is 95. Exhaust side, we're going to do 20,000 CFMs and 70 degrees dry bulb and 35% RH. All right, so let's see if we calculate what kind of performance we're looking at. And I actually realized I put 2,000, so let's do 20,000 here in the exhaust. Calculate, and there you go. So what's going on here is, as you can see, the exhaust side, we're actually just above frost. So we're at 36.55 degrees. We are saturated. And you can see that the effectiveness, if you take a look at the left-hand side, we're looking at almost 57% effectiveness. And if we take a look at our pressure drop, it's almost an inch, 9/10 of an inch pressure drop. And that's, again, because we're condensing during this condition. So our pre-treating of the outside air that we're doing is we're actually doing around 38 degrees or delta T of pre-treatment. So we're going from 3.4 outside air to 41 degrees. So I kind of want to stop here and show you guys one new feature that we had, SelectPlus. Actually, it's a new product that we've released. If you take a look on the right-hand side, you'll see an option to select the moisture eliminators. So this is something that we literally just came out with last week. We noticed that with these systems, HRMOs, and also our split passive, when you're dealing with vertical tubes and horizontal fins, condensation can be an issue, especially carryover. So what we wanted to do is give customers the option to HPT provide moisture eliminators. And what we would do is they're made in-house. They would be attached to these systems and ship out already ready to be installed into your unit. So that's a new feature for us. One thing to note is the default for this moisture eliminator option, it's going to be provided by HPT. If you don't want us to provide it, or you're going to have extended drain pans in your design, well, then what you can do is select others. And what happens is you click others, the pressure drop on the exhaust side, it actually updates. So before, remember, we're looking at 9/10 of an inch. Now the pressure drop, because there's no moisture eliminator, it drops down to 0.72. So there is an added pressure because of that moisture eliminator, but the advantage is it's a more compact design. There's no need for extended drain pans. You could just have a drip pan underneath that moisture eliminator to grab that condensation that's dripping down, and there you go. So that's something new. Wanted to point that out. If you have any questions, I believe we have more documentation online, but if not, you can always contact us at HPT and we can provide more information. All right, so I'm gonna select moisture eliminators provided by HPT. Click continue. And if we take a look at the drawings, similar to the HRMH that we saw before, but there's a note here on the towards the elevation view, and it's a note 2, and it says moisture eliminator captures condensate droplets from airstream. So if we choose not to select a moisture eliminator, if we go back, click others, and then click continue, you can see that there's no moisture eliminator shown in the drawing, so that means we're not providing anything. So again, that's something to look out for. Just pay attention to the fact that we do provide now moisture eliminators for HRMOs and for split passives. So that's the selections that I wanted to show everyone. Hopefully that made sense. I know, again, I'm going kind of quick through this stuff, but it's to give you a general idea of the layout, things to look out for when running selections, the fact that condensation does drive up performance, so keep note of that. And right now what I'm going to do is I'm going to move on to the bin analysis. So do save and close, and I'm going to run a bin analysis for Salt Lake City, Utah. And the way we do that is if we go back into the line item that we created and we go through and click calculate, there are 2 icons on the right-hand side. We've got a site chart, and below that we have a bin analysis or economic analysis. If we click that, it'll take us to this screen. So it's a pretty straightforward process. All you want to do is just follow these steps that are shown on the left-hand side. You got step 1, 2, 3, and 4. Step one is to choose a city. So we're going to go to Utah. And there you go, Salt Lake City, Utah. And we're going to click apply. So the CFMs that we input, originally selection, they get placed in automatically. Step two, it's the runtime hours. So depending on your application, that can change if you have an office space that you're working on. Obviously, you can do Monday through Friday, 8 to 5. If you have 24/7 operation, you wouldn't touch any of this. For this example, we're just going to assume 24/7. So if we go down to step three, the next step is load bin data. So if we click that, you can see that we're taking ASHRAE conditions and it's being filled all the way down from summer design to winter design conditions. And this is all coming from ASHRAE design conditions. So the next step is step 4, and that's entering your exhaust air temperatures. And we've got two options. The first option is if your exhaust temp varies, whether you're in heating and cooling mode. And your other option is if you just have one exhaust temperature year round. So I'm going to do 2 exhaust temperatures. Click submit. And you can see here that we can input 2 separate exhaust temps depending on what season you're in. So for cooling, let's do 75 dry bulb and 35% RH. And for heating, let's do 70 and 40% RH. And one thing you can do is you can set a temperature at which the outside air, when it falls below that temperature that you're setting to, it's going to change it over to the heating exhaust temperature that you just input. So in this case, I'll do 55 degrees, pretty common. Click submit, and you can see here on the right-hand side how the exhaust temperatures get updated, and they change from depending on what mode you're in. Over here on the right-hand side, we have some additional options: Economizer Mode, if you want to take that into account, and also frost control. So I'm going to select that, and we're taking into account, again, Economizer and frost control. If all that looks good, we click Calculate Economic Analysis, and it'll take us to the screen here. These are your inputs for savings analysis and also your results. It's real-time results. What you have to do is you want to make sure that you're selecting the right heating type and rates. So here, these are the defaults that we always have. Electric, 8 cents kilowatt hour. Hot water, $1.10. So if I click hot water, it's assume $1.10 per therm. If you take a look at this overall net savings in the heat pipe, I click calculate. You can see that just changed from, I think it was around 18,000, because what it was assuming before then was the fact that your cooling and heating is actually electric, which is likely not going to happen. Right now, we're assuming hot water for heating, and we're looking at a little over $8,200 net savings. And by net savings, it's taking into account the static penalty from the heat pipe. And on the left-hand side, we have some more inputs. We've got EER, if you know what that is. We've got burner efficiencies, fan efficiencies. So if you want to be more accurate, you can always update those. Play around with those inputs to get an idea of that change in savings that you're going to see with our side-by-side models. So that's the bid analysis selection portion of it. What I want to show you now is if you want to take a look at the results in a PDF document or something that you can forward to a client or engineer or whatnot. If we go to save and close, and then this line item that we just ran that bid analysis for, there's two ways of doing it. One way is you can actually do an individual report. So if we click the icon next to the schedule icon, it gives us options to output. So what we can do is let's click on bid analysis just so we can see those results, and click report. And these are the results that we just saw. So the output is going to break up into certain sections. You got cooling mode, economizer mode, You've got modulated economizer mode and full heating mode. And this is the total savings that we saw, a little over $8,200 savings per year. And also here, these are all your inputs up here towards the right-hand side. And if you want to, you can convert this into a PDF, also an Excel format, and a Word. I wouldn't recommend putting it into Word. I think there's some formatting issues, but typically we look at PDF outputs. So that's the bin analysis. I guess I'm not seeing any questions. So either I'm doing a very good job or you guys are no longer with me. But hopefully it's not the latter. What I'm going to do now is I'm going to show you guys some shortcuts that will save you guys some time. One thing that I've seen quite a bit is when you have multiple line items in a project, instead of, say, I don't know, let me copy 2 line items over. So say we've got these 5 line items. Well, if you want to select certain line items to output results, instead of doing individually, what you can do is we have a submittal included toggle switch. So whatever you don't want to include, you can just click no. So let's say we're including the first and the last 2 items. Well, once you have whatever selected or toggled to the correct position up the top, you can click submittals, and by clicking that, it's going to take you to this next screen, and you can output whatever it is you want. You can do design performance, bin analysis, psych chart, drawings, and cut sheets. So let's see, I'm going to just keep them all highlighted and do save to PDF. Sometimes this can take some time to download depending on how many line items you have. And you can see that when we get the results, what's going to happen is it's only going to include the items that we toggled to the yes position for that submittal. And we're still waiting. It's a good break for me to get some water. And there we go. So this is what SelectPlus outputs in the submittal format. So these are the 3 items that we selected. We had 5 total, but we only selected the ones that we wanted to output into this document. And we've got our results, design conditions. We've got a bin analysis. We've got a site chart, and then we've also got our drawings. So that's something that can save time so you don't have to do individual reports if you have multiple line items in a project. All right, another tip that might help everyone. Let's say that you have another project and you have similar size units. Well, what you can do, instead of having to recreate those items for that different project that you have, is you can actually select a project that has the similar units, select whatever it is you want, and instead of clicking copy to, which would copy these line items into this same project, there's a drop-down where you can actually select the project that you want to copy over to. So I just selected SLC winner and Toronto winner. If I do, let's do the test webinar project that I created previously and do copy to. So what you're going to see is if I go into that project, you can see that the 3 line items that I selected have been copied over into this project. So there's no need to recreate new line items from scratch. You can just copy those line items over. So hopefully that's something that can save everyone out there some time if you do run into those instances. And also, I think the last thing I'll show you, what we do have the option for is we can actually output all the results into a schedule format. This is going to be helpful to engineers out there if you want to avoid having to copy and pasting things into a schedule. What you can do is select whatever items you want, and down here in the bottom we have an export schedule icon. So we click that, and it's going to give you an Excel file. If we open that up, So there you go. These are all the items that we have. It's all in the schedule format. From there, if you want to remove anything, you can, and you can just input it into project documents. That's something that can definitely save some time. All right, so I think that's pretty much it, everyone. Don't really have anything else to show you. Again, this webinar is going to be available online, likely this week or next week. I guess we don't have any questions, so give you guys a couple of minutes if you do want to type something in to ask some questions. If you want to reach me outside of this presentation, my email address is john@heatpipe.com, and that's John without an H and Jon. Feel free to send me an email anytime or give me a call. My number is 813-906-3174. My colleague Bernard, he handles the southern states. He's also reachable if I'm not in the office. But any questions outside of this webinar, feel free to contact us. Looks like I have one question. They're asking any plans for refrigerants other than R410A. I think we've looked into other refrigerants. I'm not sure what we're thinking as far as the future is concerned with refrigerants. Right now, we've decided to focus on expanding our product range, which is why our glycol runaround loop we just released not too long ago. So I'm not 100% sure about the answer to that question, but that's something I can definitely follow up with everyone and give some feedback on that. But I know we have looked at other refrigerant types in the past.